This video is going to go over unit vectors and how to write vectors in linear combination form. So to start, I want you to think about the word unit in unit vectors and brainstorm a little bit about where you've heard that word before. The first things that come to my mind are units of measurement, like a foot or an inch, and then the unit circle, which is a circle with a radius of 1. And those things have to do with a length, a certain length, and that is what a unit vector has to do with. So a unit vector is a vector with the magnitude of 1. It can be in any direction. All vectors have a corresponding unit vector or a unit vector that points in the same direction. That would be a vector with a length of 1 that points in the same direction as any other vector. And we're going to learn how to calculate these. So let's take a look at a couple of vectors. So let's say u is vector 0, -3, and v is vector 7, 0. The magnitude of vector u is 3, and the magnitude of vector v is 7. So let's draw these out real quick. So that will end up being u is going to be 0, -3. And then we said v was going to be 0, 7. So we have these two vectors here. And if I want a vector that is the same direction as u, but a magnitude of 1, it's going to have to be along the y-axis, just like vector u is. And this one's pretty easy to figure out, because if you want a length of 1, you just go from 0 to 1. And that will get you that magnitude of 1. And the way to find that is because the magnitude, the length of vector u is 3. So we just divide that vector by its magnitude. We divide the vector by 3, and we're going to get this vector right here, vector 0, -1, w. So for vector v, 7, 0, if we divide that by 7, we're going to get the vector 1, 0. It's in the same direction as vector v, and it has length of 1, making it the unit vector of vector 7, 0. So if we come back here, you can see that the unit vector in the direction of vector u is 0, -1. Here we have this dividing by the magnitude is the same as multiplying by the reciprocal. So we're going to multiply by 1 over 3, 3 being the magnitude of vector u. And when you multiply that in, you get 1/3 times 0, which is 0, and then 1/3 times -3, which is -1. And you saw in the graph that that was true. It had a magnitude of 1, and it was in the same direction. And we use similar calculations for vector v. I miswrote that there. Vector v, 7, 0, multiply it by 1/7, or divide it by the magnitude, or multiply by 1 over the magnitude, and you're going to get 1, 0, the unit vector in the direction of vector v. So let's try this for another vector. We're going to try it for the vector w, which is -2, 5. So let's come back here. Let's get rid of all of that. So vector, I'm going to start here. So -2, 5. So for our first step is going to be to find the magnitude of this vector. To find the magnitude of the vector, And it's the square root of our first term squared, so negative 2 squared, plus our second term squared, 5 squared. Negative 2 squared is 4, 5 squared is 25, 4 plus 25 is 29. So square root of 29 is the magnitude. Our next step is to divide the vector by the magnitude, or multiply by the reciprocal. So here I have 1 over the square root of 29, 1 over the reciprocal, and I'm going to multiply it into our vector negative 2, 5. So you just multiply it in, so you're going to get negative 2 over the square root of 29 and 5 over the square root of 29. If we come in here and do that calculation, here we can do that by dividing by the square root of 29 divided by the square root of 29. We will get this resulting vector. And so it looks like it's about the length of 1. And if we redraw our original vector, you can see it is exactly on that line. So it's definitely in the direction of our vector. But let's double check to make sure it has a magnitude of 1. So we have our new vector, so we're gonna square the first term, so negative 2 over square root of 29 squared, plus 5 over the square root of 29 squared. Negative 2 squared is 4. The square root of 29 squared is 29. 5 squared is 25. Again, 29 at the bottom. You can already just add them together because it's the same denominator, so you're gonna get 29 over 29, which is just 1. So square root of 1 is 1. And another reason why this makes sense is because if you have any number and you divide it by itself, you're going to get 1 as the answer. So a vector has a magnitude. If you take that vector and divide it by its magnitude, the resulting magnitude will be 1. And this will always be the case. So now that you know how to find a vector of a magnitude 1 in the direction of a given vector, you can now find a vector of any length in any given direction. And you can think for a minute about how, if you want to pause the video. So you can be given a direction or a vector of any length. If you scale it back down to 1, which you know how to do, you can then multiply it by any number to get any length. So if I wanted a vector of length 8 in the direction of the vector negative 2, 5, I scale it down to 1, just like we did here, and then I can multiply this vector by 8, and the resulting magnitude will then be 8. So you can really make a magnitude of anything you want using the unit vector. Next, we're going to be talking about linear combination form. So the form you are used to is component form, and that's written as 5, negative 6. Right, just term. Linear combination form looks like this down here, and we'll get to that in a little bit. So there are 2 standard unit vectors. They are I and j. This I is not to be confused with the square root of negative 1. This I is bolded in your text, so it is different. This I is equivalent to the vector 1, 0. And so that equates for a horizontal movement. The vector j is a vertical movement. It's just the standard unit vector moving up 1 unit. And to show you how to use those standard unit vectors, we're going to take the vector v, for example, 2, 4. We can split that up into 2 different vectors, including the horizontal component and the vertical component. The horizontal component of this is just 2, 0. The vertical component will be 0, 4. It just has the vertical part. You can factor out the 2 in the first one, and be left with the vector 1, 0. Factor out the 4 in the second part, be left with 0, 1. And here you can substitute in your I and your j, your standard unit vectors, to have the form 2i plus 4j. And that's just the way to write vectors in linear combination form. Now, you don't have to go through this process each time you're rewriting it. You can just look at them here and say, well, I have a 5, so that's 5i, and a negative 6 over here, so that's minus 6j. And there you go. And that's how you write it in linear combination form. Main thing to help with this is to use linear combination form is for vector operations. Sometimes it can be a little easier. In the following case, if you have vector u is negative 3i plus 8j, and vector v is 2i minus j, and you're asked to find 2u minus 3v, you can just follow through the steps like this. You can either use component form or linear combination form to represent, and it's pretty easy to go back and forth between the two. But in this case, you have 2u, so you substitute in u as your vector up here, and you substitute in v. Distribute the 2 in over here, so you get negative 6i plus 16j. Distribute the negative 3 over here, get negative 6i plus 3j. Then you combine like terms, so negative 6i and a negative 6i will be a negative 12i, and a 16j and a 3j will end up being 19j. And if you want to convert it back into component form, you have right here, negative 12, 19. And that's it. I hope you learned from this video. Thanks for watching.